Let us review the fundamental theorem of calculus part 1 and part 2. If f is a continuous function on closed interval a and b, then you can define a new function f of x, which is the integral, definite integral a to x of f of t dt. This guy is also continuous on the closed interval, and then it's differentiable on open interval a to b. You can basically take the derivative of this function, and it is equal to f of x if you have these two boundaries. But in more general form, if you have functions as lower bound and upper bound, taking the derivative or taking the differential is equal to the derivative of the upper bound, f of vx, minus the derivative of lower bound, f of ux. They're basically applying chain rule. And finally, the fundamental theorem of calculus part 2 says if you have a continuous function at any point of closed interval a and b, and capital F is the antiderivative of f on a and b, then the definite integral a to b of f of x dx is capital F evaluated at upper bound minus capital F for the antiderivative at lower bound. Let's take a look at one example. Suppose I ask you to find the derivative of this function. Remember the formula. The general formula says, hey, to take the derivative, we take the derivative of b, f of b minus the derivative of lower bound u times f of u. So f prime of x is equal to the derivative of x to the fourth is 4x cubed. Then you're going to substitute x to the fourth into the function minus the derivative of x squared is 2x times the square root of x squared. We can simplify this guy as well. Outside the square root, it is x squared. So 4x squared times x to the third gives you 4x to the fifth minus 2x. And here you have the absolute value of x. If the question says, hey, x is positive, you can get rid of this absolute value. But in general, we leave absolute value as it is.